I'm Kate Fanning, and this is the Water Transport Lab presentation. This is my makeup assignment. And so, our first slide is about our results with the Elodia. And so, we were able to observe that the freshwater created a hypotonic cell because of a hypotonic solution. The 150 NaCl was an isotonic solution, and the 400 NaCl was hypertonic. And we were able to see this because in the first photo with the freshwater, the um, cell got noticeably bigger and kind of expanded and ballooned because of this extra water coming into the cell walls. And then in the isotonic solution, we saw that it was more of a regular shape and with less movement and clumping because it's isotonic and it's similar to its normal environment. And then the 400 NaCl, we saw a hypertonic solution because the chloroplasts were completely still and the like chloroplasts were visibly shrunken. And so on our next slide with the erythrocytes, we saw a similar thing happen. We saw in the freshwater that it turned into a hypotonic cell where it expanded and ballooned because of this water coming into it. And in the 150 NaCl, we saw that it was the most normal, presumably. They were just round and bubbly and green and very slow moving. And then in the 400 NaCl, we saw that it was a hypertonic solution because once again, the cells kind of shrank due to this lack of water inside of them. And then in the oocytes, we saw different results where the cell didn't actually grow or expand in any of the solutions and it stayed the same size throughout all of them. And so we proposed this idea that the Elodia and the erythrocytes, since they were able to react to this hypertonic and hypotonic solutions and the size of the cell changed, we believe that there are transmembrane proteins creating a channel protein that allow in the water through the semi-permeable membrane. And we believe that since the oocytes did not have that reaction with the hypotonic and hypertonic solutions, that they likely do not have these transmembrane proteins. And the way that the transmembrane protein, the water, the way that it's able to pass through is due to osmosis, where it moves from a high concentration to a lower concentration. So it moves inside of the cell or outside of the cell depending on how much water is in the solution surrounding the cell. Now, looking at this published data, we were able to see that there's two spots in the lane. This is showing that the okay, so we can see through the published data that there are these certain proteins found in the erythrocyte membranes, and that's the only thing that's really being confirmed with this piece of evidence is that these proteins are proven to be in erythrocyte membranes, and that's all we really know from this piece. Moving on to the next piece, and in this piece it adds a little bit of more information showing that when the oocytes are given this protein, they have way more permeability through that membrane, and they're actually able to absorb more water to the point where they explode. And so this data kind of shows that those proteins directly correlate to osmosis and to the semi-permeability of this phospholipid bilayer that is these cell membranes. And so we can then infer that this protein has to do with channel proteins and probably creates passageways for water in these cells. Thank you.